Hi, and welcome to week 8 of the 30-week countdown for Leaving Cert Ordinary Level Maths from TheMathsTutor.ie. As always, we have the full countdown on the TheMathsTutor.ie website for all the full members, and there's loads of videos there and everything. This week, we're going to be looking at the start of differentiation. So this is differentiation 1, and we've picked a couple of videos for everyone who's watching these lessons to show you an example of some of the things that we have for our full members. So the first video there is the rules of how we differentiate functions. So differentiating functions by rule, and this will just go through practicing how we differentiate our functions. And the second one is what's called the derivative and slope. So this is a video that just looks at a couple of examples of using differentiation and using slope. So to get started into today's lesson then, we're going to start looking at what we mean by differentiation and how we actually differentiate. So there's going to be a couple of key terms that we're going to be coming across. So sorry, now the screen just jumped a little bit too much for me there. So we want to look at a few different things when it comes to this. So we're going to be looking at a few things here. So we're going to be seeing different terms that all mean the same thing. So if a question asks me to differentiate, use calculus to find dy dx. I'm skipping this one for a second. Find the maximum or minimum value of, find f dashed of x, or use the derivative to find. All of these things mean the same thing, so these all mean differentiate. Or use dy dx, or whatever way you think about it, we're using calculus, we're using differentiation. Now, the only one that I didn't mention there, and I said I'm going to skip over a second, is this one here, find the slope of. So if I'm given a function, so I'm given like an f of x is equal to, or I'm given a cubic, so x cubed, or a quadratic like x squared, then if the question says find the slope of, I'm definitely going to be using differentiation. But remember, we do have a formula from coordinate geometry if I'm dealing with a line, with how we can find a slope as well. If I'm given the equation of a line, I can use calculus or differentiation or find dy dx, all of those things to find the slope of that line as well. But sometimes I'm not going to be using differentiation to find the slope, but oftentimes I will, especially if it's a function. So that's in one of those videos there that we mentioned to use the derivative and slope is going to be about finding the slope of functions. So we're just going to have a little practice first of what differentiation is before we actually come to look at our exam questions as we do in these lessons. So the first thing is to remind you of what is differentiation, or how do we differentiate? So the way that we differentiate is to do with the powers. So I'll be given a function, and my function could be given as f of x, or f of x goes to, or y equals. So all of these are functions, and it's a way of writing them. And what we're going to be asked to do is to differentiate with respect to x. It could be with respect to t. All that means is that my function is going to have that unknown or variable in it. Most of the time we're going to be dealing with x's, so I'm going to look at a couple of examples with x's. You might see t in there or something like that, but it's exactly the same rules. So a couple of examples that we're going to look at. So if we have f of x is equal to x cubed, and we're asked to differentiate this or find f dashed of x, what we're going to do is apply our differentiation rules. So our differentiation rules, and because this little dash is here, that's telling me that this is finding the derivative, this is using calculus, this is differentiating, this is going to be my answer. How we do this is we identify the power on our x term. So I'm differentiating here with respect to x because my function is written in terms of x. So I identify my power. So my power here is going to be a 3. And what we say with the rule is that we bring the power to the front. So I'm going to bring that power in front here and turn it into a multiply. So I'm going to say 3 multiplied by x cubed. And that's the first part of the rule, is bring the power to the front. And the second part of the rule is and reduce the power by 1. So I'm always going to be taking away 1 from the power. And when I tidy this up, I have 3 times x to the 3 minus 1. So here we're going to have f dashed of x is equal to 3x squared. So if my function is just x cubed, when I differentiate it, I'm going to get 3x squared. My second example, I'm going to say f of x is equal to 6x squared. So this time we just have a coefficient of my x squared term, so we have this number in front. But again, we're going to do exactly the same thing. So we're going to identify the power. So here the power is a 2, and we're going to bring that power to the front as a multiply. So I'm going to say f dashed of x is equal to 2 times 6x to the 2, and then I reduce my power by 1, so minus 1. So bring the power to the front as a multiply and reduce the power by 1, so take away 1 from your power. So this time I'm going to get f dashed of x is equal to, so I have a 2 multiplied by a 6, so that gives me 12, and x to the 2 minus 1 is x to the 1. There's a couple of things we have to remember about our powers. If I'm given x to the power of 1, that's exactly the same as x. And if I'm given no x's, I can write that as x to the 0. So x to the 0 is equal to 1. So anything to the power of 1 is just itself, and anything to the power of 0 is always 1. This rule here is in your tables, so your formula and tables book. So this time here I have f dashed of x is equal to 12x to the power of 1, but from our rule here we can see that x to the power of 1 is just x, so that's an answer of 12x. And we'll see that in our next example as well. So our next example, we're going to say y is equal to 4x. So at the moment, I need to identify the highest power of x. There is no power written in, so I'm going to say, well, that means we have x to the power of 1. So if I have an x on its own, it's going to be x to the power of 1. And now I'll identify that highest power of x. So that's a 1, and I'm going to bring that to the front. So I'm going to be bringing the 1 to the front, and this time I wrote it as y equals, so I'm going to say dy dx. So we're going to differentiate y with respect to x, and it'll be 1 multiplied by 4x to the 1 minus 1, which gives me 1 multiplied by 4, that's just going to be 4, x to the 0, because 1 minus 1 is 0. So I now have dy dx is equal to 4x to the 0. But x to the 0 is the same as 1 from this rule here, from our indices. So I'm going to have dy dx is equal to 4 times 1, which is just 4. And that's really important part of calculus or differentiation or finding dy dx, is that if I have an x term, I'm going to be left with just the number in front. And the last little piece that we're going to look at before we look at some questions from the tables is an example of where I have a constant. So this time my constant is just a minus 3. So we want to identify the highest power of x. So there is no power of x here. There is an x to the 0 if we wanted to be technical about it, but there is no x here. So when we differentiate this, we're going to be saying the highest power was 0, so it's going to become 0. So a constant always gives me 0 when I differentiate. Okay, so when we differentiate, we're going to get a 0 for all of our constants. So we're going to see that our functions are going to have lots of these parts coming together. So we'll have cubes and squares and x's and constants, and we're going to see a few different ways that they're going to ask me to differentiate these questions. So the first example that we're going to look at here is 2020 paper 1, question 6, part A. So question 6, part A says differentiate this function where x is a real number with respect to x. So this with respect to x just means that I'm looking at the x's and I'm going to be identifying their powers. So to identify the highest power, I see I've got a cube here, I have a square here, and this x doesn't have one, so I'm going to write in a 1. And this piece here I'm identifying, that's a constant. So a constant doesn't have any variable or unknown with it, so it's just going to be the number by itself. So when we come to differentiate this, I'm going to be saying f of x is equal to, f of x is equal to 4x cubed minus 3x squared plus x minus 7. So differentiating it is going to be f dashed of x or dy dx, it doesn't matter which way we write it. And I'm going to be saying bring the power to the front. So 3 multiplied by 4x to the 3 and reduce the power by 1, so minus 1, minus bring the power to the front, so 2 multiplied by 3x and reduce the power by 1, plus bring the power to the front, so I've put in that little 1, and reduce the power by 1. And this is a constant, so we know we're going to get a 0. So I know that this minus 7 is going to turn into a 0 because the highest power of x with it, there is no x, is going to be a 0. So when I tidy this up, I'm going to say 3 times 4 is 12. X to the 3 minus 1 is 2. Minus 2 times 3 is 6. X to the 2 minus 1 is 1, plus 1 times x to the 1 minus 1 is going to be 0. And when I tidy these up again, x to the 1 I know is going to be just x. So our 12x squared stays as 12x squared, but our x to the 1 turns to an x, and our x to the 0 is going to be 1. So 1 times 1 is just 1. So the answer to my first part is 12x squared minus 6x plus 1. And I knew that this is what they wanted me to do because they had said differentiate. So differentiate the function, use dy dx, find the derivative of, all the same sorts of things. The second part then says find the slope of the tangent to this graph. Now this graph here, we're just seeing that this is the same thing that we had up here in our first part of our question. So to find the slope of the tangent means we're going to use our dy dx or our f dash of x. We're going to be subbing in, and we're going to be subbing in our x value. So our x value here is 1. So everywhere I have an x in my f dash of x, I'm going to put in a 1, and that's going to give me my slope. So I'm going to say my slope is equal to 12 times 1 squared minus 6 times 1 plus 1, which is 12 minus 6 plus 1, and that gives me a slope of 7. So when it says find the slope of this function, I'm going to use my dy dx or use my derivative, and I'm going to fill in just my x value. So why did they give me the y value? And they gave me the y value, so they gave me a point 1 minus 5, because the next part says hence find the equation of the tangent to the graph at this point. So there's a couple of things to point out in this question and the way that it's worded. Hence. So hence means we have to use our answer. So we're going to be using our answer of our slope was 7. And what else they're asking me is find the equation of a tangent. So a tangent is a line at this point. So that was the point 1 minus 5. So they gave me the point 1 minus 5 in part 2. Hence, find the equation of the tangent. So again, from our formula and tables book, we're going to have a formula, y minus y1 equals m bracket x minus x1. And this is on page 18 of our tables, and we're going to use this to find an equation of a line. So to do this, we're going to need our slope. So m is our slope. And we have just worked out that our slope was equal to 7. And we're going to need a point to fill in as x1 and y1. So x1 here on the right and y1 on the left. So I'm going to label the point that they gave me as x1, y1. And we'll substitute. So y minus, so we'll take out y1 and we'll put in minus 5, is equal to m, we'll take out m and put in 7, that was our slope, times x minus, take out x1 and we'll put in 1. A minus by a minus, whenever I see y minus minus a number, that's the same as plus because I'm multiplying a minus by a minus. So you can do that on the calculator if you're not sure. You could put brackets around this piece and say y bracket minus 5 bracket on the calculator, and you'll get an answer of 5, which is plus 5. On this side, we're going to multiply, so our 7 is touching the bracket, so we get 7x minus 7. And then we just need to do a little bit of rearranging this equation. So to rearrange this equation, I'm going to leave the 7x where it is, and I'm going to leave the minus 7 where it is, and I'm going to subtract y from both sides, and I'm going to subtract 5 from both sides. And that leaves me with nothing on this side, and it leaves me with 7x minus y minus 12, and I'm just going to put the equal to the 0 afterwards. And this is how we'll often write our equation of a line. We put the x term first, then the y term, and then the number equal to 0. So that was the first question where we had to use our differentiation. So the first piece asked me to use differentiation, so just to differentiate. The second part said find the slope, and then using that slope, so our word hence, we then found the equation of the tangent at that point. The next question we're going to look at, 2019 Paper 1, question 3, part B. So this says the function f is defined as f of x is equal to minus x cubed plus 4x squared plus x minus 2, where x is a real number. And the part B says find the value of x for which f dash dash x equals 0, where f dash dash of x is the second derivative of f of x. Now, I'm seeing my dash and I'm seeing this word derivative, so I know that this has something to do with this dy dx differentiation using my rule, but what's different here is that we have two little dashes. So when we have two little dashes, what this tells me is do it twice. So I'm going to differentiate, which will give me f dashed of x, and then I'm going to take that answer and I'm going to differentiate it again. So because there's two little dashes here, that means I'm going to differentiate twice. So we'll start with writing out our function. So f of x is equal to minus x cubed plus 4x squared plus x minus 2, and we're going to identify the highest powers of x. So I can see I have a cube, I have a square. There's no power on this x, so I'm going to write in that we have a 1. And I see this constant here, this minus 2, and I know that when I differentiate a constant, I know that I'm going to get a 0. So when I differentiate this f dashed of x, I say bring the power to the front, so minus 3 multiplied by x to the 3 and reduce the power by 1, plus bring the power to the front, so 2 multiplied by 4 times x to the 2 and reduce the power by 1, plus bring the power to the front and reduce the power by 1. And I know that this constant is going to become a 0, so I can just write in 0. So I'll tidy this up a little bit and we'll say that's minus 3x squared plus 8x to the 1 plus 1x to the 0. And we know that x to the 0 is going to become a 0 when we differentiate, or excuse me, it's going to become a 1. So that will become plus 1 times 1. But I'm going to leave my power there for now because now this isn't my final answer. I'm going to have to differentiate again. So now we're going to find f2 dash. So we're going to do the same thing. So I'm going to highlight my powers. I have a 2. I have a 1, and this time I have a 0, so I can use that 0 as I go along. So I'm going to say bring my power to the front as a multiply and reduce my power by 1. So the 2 comes to the front, so minus 2 multiplied by 3, x to the 2 and take away 1, plus the 1 comes to the front as a multiply, times 8x to the 1 minus 1, and you can see that that 0 comes to the front, because that 0 multiplied by anything is going to be 0, because that would have been a constant if I had tidied it up. So if I had tidied up this piece here, I would have said that's plus 1 times 1, which is 1, and I know that that will give me a 0 because it's a constant. But we can see why there, because as we bring the power to the front, I'm going to have 0 times something, and 0 multiplied by anything always gives me 0. So when I tidy this up, I get minus 6x to the 1, plus 8x to the 0 plus 0. So 0 times anything is 0. And again, I'm going to tidy that up a little bit more and I get minus 6. Well, x to the power of 1 we said is the same as x, and x to the 0 we said is the same as 1. So 8 times 1 is 8. So I'm getting an answer of minus 6x plus 8 for my second derivative of my function. So then we have to look at what the rest of the question asks me to do. So the rest of the question says, find the value of x for which it's equal to 0. So now I'm going to take this answer here and I'm going to put it equal to 0 and we're going to solve for x. So find the value of x is the same as solve for x. So minus 6x plus 8 is equal to 0. I'm going to subtract 8 from both sides and then I'm going to divide both sides by minus 6. And when I tidy that up on my calculator, I get x is equal to 4 over 3. So again, I saw the word derivative here telling me differentiate, do dy dx, do f dashed of x. What was unusual here is that we had two dashes, but all it meant was do the differentiation twice. So when you pick out your powers, bring the power to the front and reduce the power by 1. Once you've done it once, you just repeat it again, and we say this is f2 dash of x, or d2y dx squared if we were using our dy dx symbols. Okay, the next question that we're going to look at This is 2016 paper 1 question 4, and we're going to see that this will have a bit about functions and a little bit about slopes and tangents and things like that in it as well. And we have the full question here. So the first part, part A, gives me the function f of x goes to x cubed plus x squared minus 2x plus 7 is defined for x a real number. Find the coordinates of the point at which the graph of f cuts the y-axis. Now that doesn't have anything to do with differentiation at the moment. What I need to know is that when something cuts the y-axis or crosses the y-axis or intercepts the y-axis, they all mean the same thing. X is always going to be 0. So what I'm going to do is I'm going to use substitution, and I'm going to sub in a 0 everywhere I have an x into my function. Now this part of the function often causes problems for people. F of x like this is the same as y. So often I'll rewrite that as y equals x cubed plus x squared minus 2x plus 7 before I start, just to make it a little bit easier for myself with the y. So we're going to say x is equal to 0. So everywhere I have an x, I'm going to sub in a 0. And my calculator is going to do all this work for me. So I'm going to say 0 cubed plus 0 squared minus 2 times 0 plus 7. And that's going to give me the answer of y is equal to 7. That's where it cuts the y-axis at the value of 7. But this question said, find the coordinates of the point. So anytime I want to have coordinates of a point, we always have to have an x value and a y value. So the point is going to be bracket 0, because that's my x value from here, comma 7, because that's my y value from here. So the coordinates of the point where this function crosses or cuts the y-axis is going to be at 0, 7. Part B says verify using algebra that the point 1, 7 is on the graph of f. To verify something, we're going to substitute it in. So I'm going to sub this into my function. So everywhere I have an x, I'm going to put in a 1, and everywhere I have a y, I'm going to put in a 7. Now remember, this f of x written as y makes this a lot easier, because now I have y is equal to x cubed plus x squared minus 2x plus 7, and we're going to take this and we're going to substitute in my x and y values. So everywhere I have a y, I'm going to put in a 7. Sorry, made that pen too thick there. So I'm going to put in a 7, and everywhere I have an x, I'm going to put in a 1. So I'm going to say 1 cubed plus 1 squared minus 2 times 1 plus 7. So you'll notice that this equation has numbers on both sides and there's no letters in it anymore. So I'm not solving for a letter. All I'm going to be doing here is showing that the left-hand side is equal to the right-hand side. So when I substitute in my x's and my y's, if I get the left-hand side of the equals to be equal to the right-hand side of the equals, then I know that that point is on the line. So this is just a 7. That doesn't need to be changed. That becomes 1 plus 1 minus 2 plus 7, and that gives me 7 is equal to 7. And your calculator will do that right-hand side of the equation for you there if needed. So when I get 7 is equal to 7, that tells me that A, 1, 7 is on the graph. So, sorry, I think I said on the line. In this case, it's not a line, it's obviously a cubic graph. So we're going to see that the point is on a graph by substituting it in. And it would be exactly the same to show that a point is on the line by substituting it in. But here we're showing that the point is on the cubic graph by subbing in our x value and our y value into our function. And once we get the left-hand side of the equation equal to the right-hand side of the equation, that proves that a point is on the graph. So we haven't had to use our differentiation yet, but I see in part C that it says find f dashed of x, the derivative of f of x, and then I'm going to see a hence. So I'm going to have to use that answer, find the slope of the tangent. Okay, so we've got a few parts here that are telling me I'm going to be using differentiation. So find f dashed of x, the derivative of f of x. So we know we're going to identify our powers. So we have an x cubed, an x squared. we will fill in a 1 on that x, and we know that that 7 is going to become 0 because it is a constant. So I'm going to be saying bring the power to the front. So I'm going to say, so it has written f dashed of x for me. So I'm going to say 3 multiplied by x to the 3 and reduce the power by 1, plus 2 multiplied by x to the 2 and reduce the power by 1, minus 1 multiplied by 2, x to the 1 minus 1, and we know our 7 becomes 0. So when I tidy this up, f dashed of x becomes 3x squared plus 2x to the 1 minus 2x to the 0. And we know when we tidy that up a little bit more, 3x squared stays as it is, x to the 1 changes to just an x, and x to the 0 is 1, so minus 2 times 1 is minus 2. The next part says hence, so we need to use that answer, find the slope when x is equal to 1. So we're going to sub in 1 for x, so when x is equal to 1, we're going to be saying f dashed of x is equal to 3 times 1 squared plus 2 times 1 minus 2, and when we put that into our calculator, we're going to get an answer of 3. So my slope, which I'll fill in here, is 3. And the last part of this question, hence. So again, using that answer, find the equation of the tangent to the graph at the point 1, 7. So we did one of these already, but just to finish off this last part of this question, I'm going to need my equation of a line formula for my tables again, and I'm going to write it here. So y minus y1 is equal to m bracket x minus x1, and we need our slope. So we've just worked out that our slope was 3, and we need a point, so that's x1, y1, the point 1, 7, which we were told was on the graph, and we proved it. So we sub in y minus 7 is equal to 3 times x minus 1, and we're going to multiply out that bracket, which gives 3x minus 3. And again, I'm going to leave the 3x and the minus 3 where they are, but I'm going to subtract y from both sides and add 7 to both sides. And when we tidy that up, we get 3x minus y plus 4 is equal to 0. So that's my equation of the tangent to the graph at that point. So that's our introduction to differentiation. So again, there's 2 videos for you there. One that'll go through those rules that we've looked at about bringing the power to the front and reducing the power by 1, and one that'll do a little bit more work on the slope and the derivative of slopes. Okay, hopefully that was of use to you. Thanks.